Hello chemists and welcome to this episode of Bales Chemistry. Today we're talking all about the shapes of complexes. It's 2.5 transition metals in the AQA A-level specification and it's going to appear on paper 1 of your final A-level exams. If you haven't already, make sure you subscribe to the channel and hit the notifications icon so you don't miss out on any of the videos coming up about transition metals. So when we talk about shapes, then we might want to cast our minds back to the topic we did in the first year, where we talked about shapes and we looked at different sort of pairs of electrons, bonded pairs, lone pairs, and we worked out what shape the molecule will be based on that information. So when we look at transition metals then, we're going to look at the coordination number. That's the number of coordinate bonds formed by the ligands to the metal ion. Once we've got the coordination number, all we need to do is pick the right shape that goes with it. There are a few examples that we need to know for the AQA A-level chemistry syllabus, and we'll be going through those in the next couple of minutes. It's also really important that you know how to draw the different complexes, and it's worth spending a little bit of time practicing drawing out different shapes and different complexes. Some of the examples that are given in the next slides below might give you some ideas. We'll start with a coordination number of 6. We see this when we've got 6 small ligands. This is ligands like water and ammonia. These form octahedral shaped complexes, and when we draw these out and they've got a charge, we must remember to put the square brackets around them and put the charge up there in the top right hand corner. Bidentate and multidentate ligands also often form 6 coordinate bonds, and that gives us an octahedral complex as well. Here we can see a cobalt complex with 3 ethane ligands. These ligands are bidentate and each form 2 coordinate bonds to the metal ion. This gives a total of 6 coordinate bonds, leaving us with an octahedral complex. Bigger ligands such as chlorine tend to form 4 coordinate bonds to the metal ion, and that gives us a tetrahedral shape. Here we can see a copper complex with 4 coordinate bonds from 4 chlorine ligands. Some complexes with 4 coordinate bonds actually form square planar shapes. This is particularly common with complexes around the metal ion of platinum. An important example of that is cisplatin, and we'll look at the chemistry of this in more detail when we look at isomerism and when we look at the chemistry of DNA. Complexes with only 2 coordinate bonds are a little bit more rare. The silver metal ion tends to only accept 2 coordinate bonds and forms linear complexes. So to summarise what we've looked at today then, small ligands, bidentate ligands and multidentate ligands tend to form octahedral complexes. Bigger ligands, like chlorine, often form tetrahedral complexes. Platinum complexes with 4 ligands are square planar, and silver forms linear complexes with only 2 ligands. Hope you enjoyed watching this episode of Bales Chemistry. If you have, why not give us a like below? And if you've got a bit of time, why not check out the link on the screen now for the Transition Metals playlist, or check out some of the other Bales Chemistry episodes.